A lot to cover today. I'd like to start with a kind of end state in mind and work back to the base, the like concepts and technologies that make this kind of end state possible. What I'm interested in right now is not, and this talk is going to focus not so much on AI code authorship in the IDE as we know it with Copilot. Well, pick your code assistant, right? There's like a million of them at this point. Not so much the ghost text, like select the next token in the wherever my cursor's pointing, but rather how do we start to understand our entire estates? Like, where are all the usages of Guava in 10,000 applications, 50,000 applications, or how do I upgrade that across 10,000 applications or 50,000 applications? This might be a bit too loud. Yeah, I'm kind of a loud person by nature, so maybe cut it off at the top. Yeah, so with that in mind, I'll show kind of like a quick experience using Claude Desktop. Claude Desktop, if you aren't following the state of how things are going, along with many other large foundation models, are now imbued with a concept called tool function calling. That is, they allow you to provide basically programs or just functions, input, output. It's like regular RMI, RPC type stuff, right? And then a description of what that tool does. And then when you're asking a model something, that model has a question that it thinks that tool can answer, it's going to ask the tool for it to do some sort of work. And so in this context, what I think we're looking for is something like this. I want to start and say kind of like, how is Guava used across a large organization of codebase? The first thing that I have to do is somehow supply to this desktop client the set of tools that are available to it. And this is the way to do this right now with one of the desktop client, or Claude Desktop client. It's called Model Context Protocol. Model Context Protocol itself is there's not a lot to it here. It's just really a protocol, a way of calling tools. This could literally be Java RMI. It's not much different than Java RMI was or any other RPC technology. It's just a way of calling tools that Claude Desktop happens to support. I've added a Model Context Protocol server, which implements a set of tools to this desktop client here. And if I just look at the set of tools that it supplies, I can see the sort of 6 different tools. In this case, the ones I'm providing, and we'll get into what this means in a moment, but are the ability to search for open rewrite recipes, to run them, to ask more about them, and so forth. And so we won't get into that too much just yet, but you see maybe I have a tool that allows it to send me a SQL query and I'll run it. It really could be anything at this point. And then I'm going to ask this question, how is Guava used? Now, the model in its training set has no idea, how Guava is used in my code base in particular, right? I mean, I think that's fairly clear. It's going to want to ask some tool to provide help. And in this case, it's saying, yeah, I would like to help you find Guava, but yeah, I need help here. I'm going to look for recipes. Again, we'll get back to recipes in a moment, but I'm going to look for recipes that I think could answer this question for me. And it's going to it's going to look for them. This, like what you see here, this kind of black text box is it executing a tool and you see in the response. Ultimately, it's looking at this recipe about no Guava, decides that isn't quite what it wants. It looks for another one. It finds this recipe called find method usages and decides that this is the way that it's going to try to understand how Guava is used in the code base. And if you kind of zoom in here for a moment, or I'll just pause this, you can see how it's using this find methods tool. And that tool requires an option. So that tool requires an option that somehow you specify a method pattern. And so the model has used its own training set and knowledge to translate Guava into, I know this means the package com.google.common, and it's looking at this recipe and the tool definition and seeing how do I specify that method pattern. And so it learns from this recipe how to specify this method pattern, com Google common star, any method name, any number of arguments, and it's going to run that recipe. So at this point, the control has passed from the model back to my tool, and it's running some back-end process. It's running some deterministic process probably to go locate all of the usages of that thing. And just to kind of zoom forward here a little bit, it's also going to describe what kind of data it wants out of that. And at the conclusion of that tool call, it's able to take all the data, that comes back from that response and summarize it in some way. So the tool, that recipe, identified accurately that there were 4 specific usages of Guava in this hundreds of repositories, right? Returned all of those results to it, and it's able to kind of say, okay, these are the 4 patterns that I see in play in this code base. I think what's interesting is you can go kind of one step further here. So you can say kind of like, okay, now that you've been able to see all that raw data, can you build me this histogram that shows me, something about how, the prevalence of those various different features that I saw in this code base. And here again, it's looking back to the raw, in this case, like CSV output of that tool. It's kind of churning through the actual results that came out of that tool, and the model's going to think about it for a little bit, and then potentially write a little bit of code. So it thinks, okay, I've seen all the data, now I'm just going to write a React component real quick here, and after I'm done laboriously spitting out a bunch of JavaScript and HTML here, basically a bunch of React code, this is the representation of how many usages of what types of Guava patterns I found in that code base. So this is an interesting world, right? It's a combination of, you have these like non-deterministic LLMs doing research using tools that themselves are more deterministic. When it comes to code in specific, I think a lot of the things we want to know about code are not visible in just the text of it. So if I were to go to Google code search right now, or GitHub code search right now, and just look at one of my organizations and just type where is Guava, like this isn't going to work out super well, right? Because I'm not actually looking for Guava. I'm looking for something that represents. What does that represent? That kind of has to be transferred into something else. Does that experience kind of make sense here? This was a multi-repository experience doing a search for that on tens, hundreds, thousands of repositories. So if we start with that kind of end state in mind, I'll have to like rewind now 10 years to kind of build us back up to this point. I had joined Netflix Engineering Tools about 10 years ago, and there one of my responsibilities was trying to move people forward onto the latest versions of things. So Java 6 was being retired in favor of Java 7. Then Oracle changed its licensing on Java 7, so we quickly had to move from 7 to 8. Otherwise, huge bill coming from Oracle. I don't know if anybody remembers that. We were trying to kill off an internal logging library we called Blitz4j, which was basically just SLF4j, and then we regretted it. We should have just used SLF4j all along. The problem for us was there was only 2 of us on engineering tools, and there was like 700 engineers. And so we did a lot of work on providing context, building basically early forms of internal developer portals a la Backstage to try to like surface in front of people like, here's where you are relative to where we want you to be. We hosted workshops, we did contests, we tried to bribe people in various ways. Here's a bottle of champagne if you move forward. It resulted in approximately 0 movement towards the objectives that we were setting as a company. And Netflix had this freedom and responsibility culture, so we couldn't impose a constraint on a product team. You couldn't say, like, on a certain date, if you aren't I'm shaking you, if you aren't on this, then I'm going to just break your build, right? Not okay there. So, no matter what we seemed to do to provide context, people wouldn't do anything. So we would say, what could I do? They'd say, do it for me, otherwise I got something else to do. So do it for me. Well, there's only 2 of us. There's 700 of you. We only stretch so far, right? So that's why I started seeking ways of automating the code change itself to allow people to move forward, basically do the work for them while still having them be responsible for committing it. So at that time, I founded a project called Open Rewrite, and that was about, it's about a data structure we call the lossless semantic tree that has not just the text of the code, not just the abstract syntax tree, but everything the compiler knows about these types and so forth. And then a set of programs we call recipes, which transform those trees and get materialized back out to source code to produce some sort of change. To see one of these in action now, and then I'll show you a little bit about what the data structure looks like. If I were to, go to like a business unit, say 175 repositories, and say, I want to move this to Java 21, the recipe is going to make, well, actually this is hundreds of recipes all stitched together at this point. That means move to Java 21. The recipe is going to move your, I'm going to make this a little bit bigger, like move your GitHub Actions stuff. It's going to, it's going to make the update Gradle wrappers as necessary, which you can kind of see there. It's going to actually make code changes as well. We want to teach developers. We want to say, why did this change? Well, we're replacing paths.get with paths.of because we're trying to move to 11, and that became the idiom in Java 11, because we're trying to move to Java 17, because we're trying to move to Java 21. And so the idea is to have this deterministic program, a recipe that can go through and make this change, not just on one repo, but on thousands or tens of thousands of repositories at a time. So you can just say, go, right? Go to this end state. At some point in my journey, I left Netflix. It went to Pivotal. That's where I met some of the folks around here. We were trying to work on an unrelated product, and this is what we kept hearing people struggling with, trying to keep things moving forward. So we actually went and invested a lot of our time into and this is what we do today, expanding this capability to provide all sorts of kinds of transformations, from Java migration to move from Oracle to Postgres to one platform to another to whatever, a lot of different kinds of changes. What's interesting about this particular thing right here, you see paths.get, right? And so I'm trying to identify a function that has a method called get, and I'm trying to change it to of. But I guarantee you, in the world of all Java APIs, there's more than one library that has a type that has a method called get. I think we would agree, right? And so it's not good enough for a recipe to just say, well, first of all, you can't just say find and replace get with of. I think that's pretty clear. But even if I had an abstract syntax tree and I could say I could only winnow this down to every method called get, it still wouldn't be good enough, right? I have to be able to say, is it of this type? Now, this paths right here could have been statically imported. It isn't in this case. It could have, so that all I see here is get. And it could have been statically imported, and paths was actually under a wildcard static import. So I didn't even see the word paths anywhere in this source file, right? And that's part of the problem. When that very first problem I'm alluding to, when I was trying to move Blitz4j, remember the regrettable logging library that we decided to write internally, when I was trying to move that to SLF4j, it looked something like this. It looked like logger.info or something like that, and that looks eerily familiar to SLF4j, right? Like in many ways it had very similar syntax, but it was not the right library. When I think about this example class right here, this is a class called dog extends animal. Logger is, in this case, in this contrived example, a protected field I'm inheriting from animal. so that in this code, an animal could be coming from a binary dependency, right? So in this code, there's no reference at all to like what the type of that logger is. There's no import statement. There's no type definition. I can't like follow the definition of logger back to where it was declared because it isn't declared here anywhere. It's coming from somewhere else. So if I wanted to write even just a code search that uniquely identified all calls to blitz4j info, I could not do it with just the abstract syntax tree alone. That was really the like kind of problem that we were facing at the beginning. The representation that Open Rewrite uses something we call the lossless semantic tree. And so if you think about the syntax of this class, the syntax is all the green nodes. It's like there's a overarching file compilation unit. There's a class declaration for dog. There's a block that is inside that class declaration's body is in. There's a method called speak. So you could break it down into its syntactic elements. What we're adding to this abstract syntax tree is everything the compiler also goes and solves about it. So when you see this particular method invocation info, there'll be another node hanging off of that tree which says this is the declaration of that method. This is its declaring type. This is that declaring type super interface and super classes and all their other methods and all their arguments and all their super interfaces. And so you could be looking at one method here and there could be a million nodes hanging off of this on the graph because it's going to work its way all the way up, the type hierarchy and across all the different arguments that are touched by it and so forth. But that is the information density that ultimately we need to do meaningful large-scale transformation or to do large-scale search. Kind of back to that Guava situation earlier, if I were to ask a language model, go find me all the usages of blitz4j, and all the language model has is the text of the code, there's no way it could understand whether this was blitz4j or slf4j, any more than I can as a human just looking at this example in isolation. I think it's a common hope right now that the model will just get better, that it'll we'll just have GPT 85 or whatever, and it'll be trained with everything that could ever be, and then it'll be fine, right? But it's if it isn't supplied with the right data, it just is not going to be able to make accurate decisions. And so interestingly, I think a lot of what we started working on 10 years ago to try to collect up all this information about the code in this sort of tree form winds up being, when you can expose it to models as tools in this form, is just this massive superpower for a model that right now is actually quite sufficient enough, when supplied with the right data. I would like to give you a sense of some of the other kinds of recipes that are possible, and then imagine for yourself, I think, a model that's able to use these in combinatorial ways to either perform some sort of impact analysis or to make some sort of transformation. And I really want to emphasize to get this point across, how much information is not visible just in the text. So I have an example from Allstate, a year or two ago, where they were looking for REST endpoints that produced personally identifiable information. So if you think, again, imagine I go to GitHub code search here, and I say, REST endpoints that, I'm not going to get a great result, right? This is true of really any code search technology. I could go to SourceGraph, right? And I could say REST endpoints that, and I'm going to get a similarly garbage answer, right? Because what does it have? It has text, it has abstract syntax tree, maybe. It doesn't really know anything beyond that. This recipe was written as a program to define, I think, what it means to be a REST endpoint. That it has a certain annotation on it, that it has a certain type of configuration, that it looks a certain way. And then it knows that in this case, the response, the method return here, or the return type, is the response to this particular API endpoint. And so you can see that Vets here in Pet Clinic has a vet list, which in turn has a person, which in turn has a last name on it. So if I said to you, last name was a piece of PII here, looking at the lossless semantic tree version of this, the recipe can dig down through that type attribution. It can get into this blue information. It can start drilling down into the domain objects themselves and looking at the fields that are defined on those model objects, potentially transitively a few layers down, and it can say, I found this piece of data somewhere, hidden underneath the surface of what just says vets there. So a couple other, I think, quick examples of this. I think you have, I like to run this one sometimes. I worked for the Spring team for a little while, so I'm not picking on them too much here, but I wrote a recipe that just looks for usages of deprecated methods. And so in particular, I decided to look for usages of deprecated Spring APIs in the Spring code base, right? And they have 150-something, 6 repositories, something like that. And you can see there's 610 files that have deprecated usages of their own stuff. They probably don't know because you know how it is. If you open a file in the IDE and it has a little yellow squiggly line on it, you go, oh, maybe I have to do this. But the problem is, we don't have every file in our whole code base open every day, right? So it's difficult to keep up with this stuff. This, again, is there's nothing about the syntax of set LOB handler here that tells me that it's deprecated. But if I'm looking at the type information here, I could determine that, it's at that point just looking at the declaration of that method, I can see that it is. And so it can kind of tag that as something that that's deprecated. We allow Open Rewrite recipes to produce something we call data tables. And this wound up being a real superpower for these LLMs in a way that we didn't expect, I think, when we created them. So we're looking at all the individual results. That's nice. But if I were to ask you the question right now, okay, of these 610 files that have deprecations, what is the most common deprecation that's afflicting these repositories? Hard to know, right? Because I'm looking at individual results. And so we allow a recipe to produce structured data. We call a data table. And the recipe will just emit rows of data, rows and columns of data that when downloaded, I think I may have one of these open somewhere, will be all the ways in which deprecated APIs are used. So it'll be like this file had this particular method call, in this case a constructor, which was deprecated. This is the declaring type, this is the method name, these are the argument types. And now I could just go through that table and just basically do a pivot table and say, sort by, boom, this is the most common thing that I'm doing that's probably vulnerable to breakage in the short term. This tabular data here, like this, models find a very easy time reading this kind of thing, right? They're not that logical. So when you give them information in this very rectangular form, they can reason about it. You could see Claude earlier. If I were to do the same thing and say, find use of deprecated methods, show me the ones that are most vulnerable to breakage, it would do that same kind of pivot table, blah, 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 kind of thing. Here's the result. So think about that, I think, with your data as well. Any way you can kind of take complex data model objects and flatten them into two-dimensional data structures to give to a model, you're kind of giving it, and supply it as a tool, you're giving it a superpower that it doesn't have in any other way. The lossless semantic tree also has something we call markers on it. Markers are just this data that's environmental about it. So when I look at a pom.xml, a Maven pom, the XML of a pom is alone insufficient for me to know what all dependencies are coming in, right? Because those a lot of dependencies are coming in transitively. Some are defined in the parent. Some are coming in through profiles that were activated by settings. So that there will be a marker on the lossless semantic tree called Maven resolution result which has a reference to the parent and its parent and its parent and all the profiles that were active and all their dependency management sections and all their properties. And what that enables is us to do things like, with these recipes, like upgrade dependency version. We were talking about Jackson earlier. Upgrade Jackson to the latest patch release of the minor I'm already on, whatever that may be. And so to this repository, it took 243 to 246, but to some other repository, it'll do some other thing, 213 to 213.2. You can conditionalize it depending on, how that dependency came in, what it looks like. These recipes seem simple, right? That's like that we've been showing one thing, like find methods, or like change method name, or find dependency, that kind of thing. These recipes get compositional, so we will stack them together to form higher and higher units of work. In the case of like something like Spring Boot 3.4, this recipe now, this is just kind of a DAG visualization of the recipe's composition itself. So to migrate to Spring Boot 3.4 has 3,300 steps to it. You first have to migrate to Spring Boot 3.3, which means you have to move to 3.2, which means you have to move to 3.1, which means 3.0, which means you have to migrate to Java 17, which means you have to get to 11, right? And so each one of these, like this Java 17 here, this is its own recipe. It's like this little subgraph here that's highlighted is one unit of work, but it's encompassed in the larger unit of work of I'm trying to move to Spring Boot 3.4 right now. We find that to make people like accept change most effectively, they have to be able to pick components of this type of automation. They need to be able to say like, yeah, I know you want me to get to 3.4 right now, but like I'm just going to get to Java 17 first. Like let me just ship that, and then I'll come back to the larger thing, at a little bit of a later time, if that makes any sense. This gets to another point. I think seeing the depth of something like this, gets back to another point about like, if I were to just envision a future where I ask a model to just take 1,000 repositories and just migrate them all to Spring Boot 3.4, my presupposition is that that model knows about all 3,300 of these steps. I don't think it does, and I think, so you think, well, how could we add, and I think there's a lot of discussion around how can we add verification steps so that, we let it run, it fails to do some stuff, but it's going to fail compilation, right? And so then we'll just put it in a loop. We'll like let it run, we'll put it through compilation, we'll see what the errors are, we'll have it do those, fix those, et cetera, et cetera, et cetera, et cetera, right? And eventually, hopefully, we'll get to a working state. I think there's a lot of kinds of changes, and we should all kind of like that, if we've been around long enough, we kind of know this, that there's changes that will elude verification. And so all these green nodes here are all the places where the Spring team made changes to property names. So in application.properties or application.yaml, you have to know to go back and make that change. Some of these will fail test harnesses and things of that sort, but imagine a change to something that impacts the way your thread pool is configured or your telemetry tags are configured or something like, and a telemetry tag gets dropped and now an alert no longer fires under duress because that it just disappeared, right, from your monitoring system, and the alert wasn't configured to fire on no data. So there's a lot of like underlying like things like that that elude basic verification in the form of compilation or our tests that are yet still important. And I think what we find oftentimes is we'll go and run this automation, like even a Spring Boot 3.0 or 3.1 or 3.2 or 3.3, whatever migration, on a code base that a team believes they've already done by hand. And we find a lot of these kinds of things that have been missed along the way because it was, whoops, like I didn't know about that, that kind of thing. So I think the general point I'm trying to make is that, and this is something to think about, I think, with agentic workflows in general, is that verification only is as good as like what kind of verification sources do you have available to you? And in the case of like compilation verification, that only verifies positively identifiable, like, I made this incorrect change, it fails compilation. It's hard to verify the negative space of what the model did not choose to change. And that's also something I don't see kind of an obvious solution for. So is there anything else? I think I've covered a lot of different kinds of things. I'm happy to kind of take this in a lot of different ways and happy to make this a bit conversational as well. So does this make sense?
I'm more interested in how you connect the recipes.
Yeah.
You said as a standard, how would they connect?
How do they connect in?
MCP.
Oh, I see. The MCP standard itself. Yeah. I think I could show you some examples here of like of what this tends to look like, and it's not going to be too surprising to you. It's like, you've got this is like a LangChain4j tool definition. This is a Quarkus MCP tool, and you've got tool arguments as well. So really what you're doing is you're defining, Spring AI has something similar. It's basically just any method can be a tool. It's got arguments like normal, and you're really providing descriptive text on what this tool does and what your expected arguments are in this case. I think we just went, the problem can be that, some models, I think almost all models now have a limitation on how many tools you can provide them at any given time. And it's in like the low hundreds. It's like 110 or something like that. It depends on the model. But in our case, we have thousands of recipes. So how do I choose which of the set of recipes to supply? I think what we decided to do was add a tool on the front of all of that that's just like, you tell me when you want a recipe, I'll go look behind the pile here, and I'll just tell you the 20 or so that I think are best for you. You select one, you decide to run it. And that's a way of like circumventing that limitation.
For that graph you were showing of the enormous Spring Boot migration recipe, and you were showing like the subparts for Java 17.
Yep.
Like how are those recipes composed? Because is it like with tools like this, or is it open rewrite directly that you're?
This is an open rewrite directly. So if I look at the definition of one of these recipes, so I went to like a migrate Java 17 recipe here, and I look at the details of this, I could just go to the recipe source here. In this case, this is a declarative recipe. So it's a recipe that just has a YAML definition with a list of all the other recipes that it provides. The further down the stack you get, the ones that are, programs themselves. If I look for like change method name, and I look at this recipe source, it's actually a class. So it's actually code, and it has these options defined on it. And it's precisely these option names and descriptions that when we return a set of recipes that against a recipe search back to the model's reading all of these option descriptions, so that when it says, okay, yeah, I want to do a change method name, it's learned how to use method pattern here from the description on the recipe itself.
But yeah, the description really matters. That's what
it does. Yeah. It does. And so to the extent that I can go through the catalog and improve the descriptive text of the recipes themselves,
it's like a prompt.
It is. Yeah. It is. Yeah. It's prompt engineering in the specific form of how this tool is. I want to repeat the question so you know, how do you parse Gradle code? Because Gradle has initialization and everything, and so it's not. This is actually a general question that's applicable to Java code as well. It's not good enough to just run like an Antilar Java, grammar on something like that and get just the syntax back. I actually have to invoke the Java compiler. I have to guide it through its first couple phases, look at all the symbols that it solves for, and pull all those out and stick them on the model. And so similarly for Gradle, we actually exercise Gradle through its initialization phases. I've parsed the Groovy or Kotlin over here as syntax, and now I layer onto that syntax all the state information post initialization. That was
You actually from Gradle process and extract the data.
yeah, right, yeah. So part of the problem I think we have, and this, so we have a modern CLI. It's just you point it at a repo and you say build, and the hard part of that work is actually trying to figure out how to build the project, because it could be Maven, it could be Gradle, it could be Maven, and it could be JavaScript at the same time. They're just in different folders. It could be on Java 17, it could be on Java 8, it could be on. Well, think about the problem of even like, how do I detect the Java version when it isn't defined in the repository? Specific, like, what is a signal of Java version? Well, sometimes you have a source compatibility equals 1.8, or sometimes you have an SDK man file in there, or sometimes you have a .java_version file in there, or sometimes you have a version of Jacoco that doesn't work post Java 8. That's a signal. And so we have hundreds of these signals that all try to, and we do this constraint satisfaction problem and say, I'm looking at this repo, okay, you're Maven, okay, I know you're Java 8, and I'm going to inject myself into you in a certain way to exercise the compiler and the build tool and then rip all this information out. So this is where, obviously this problem is, its own like year's worth of effort. I think that a lot of people don't want to do that work. I think it's like the wishful thinking of like, isn't a model just going to get smarter, right? I was in the Army for a long time. I had this colonel that would say, hope is not a course of action, right? I think that's the world we live in. Yeah.
Sorry to go back to this.
Yeah.
Does MCP support role models now, or?
Not really. So MCP, I think, and again, this is model context protocol. This tool definition looks an awfully lot like just remote procedure call, right?
Yeah.
It's just a method with arguments. It's like nothing super, new. MCP says, okay, you're going to call this method via stdio or WebSockets. Like it constrains the way you're going to call it. It's really, I think you can see it as, if you are familiar with this commoditize your complement sort of concept. I think we can get this blog post, but I think it's Anthropic's attempt to define a standard to make itself more relevant, basically.
But all models support tool calling.
They all
not all of them support MCP.
Right.
That.
Yeah, if I opened OpenAI Desktop, there's no way to like attach an MCP server to it. But because Claude did it, I think what Anthropic's trying to do is force OpenAI to also support that same standard in the absence of any other standard.
So technically, if I built my own recipe to some database with certain things and a good description, it could be used with any LLM. A lot of them.
Exactly. Yeah. I mean, so this is part of the idea is that for the folks we work with, they write a lot of custom recipes that are unique to them, and so they'll look for constructs that we don't know anything about. And they get added to their marketplace, and then now the LLM becomes aware of things that are unique to them as well, because it's just another tool that's undifferentiated from any of the other tools at its disposal.
So you don't have that context limit anymore. You can go.
Exactly. And this could, you mentioned context limit. It's, for those that haven't kind of worked on this yet, you've heard of retrieval augmented generation, or RAG, right? RAG was, you think of this in terms of like in the sequencing and time, RAG came before tool function calling. And RAG is basically like prompt stuff, a bunch of stuff at the front of the prompt, and then ask a question. And hopefully, it's using the information you stuffed at the beginning of the prompt to answer this question. How would I do that for the like, how is Guava used, before I know you're going to ask the question, how is Guava used? I couldn't prompt stuff the whole universe of information that I have about the code at the front. So, the tool function calling basically is like an inversion of control moment for some sort of retrieval, where the model decides when it wants that information, and you need to supply it at the time and place when it asks. Hopefully that makes sense as well. It's like a miniature IOC moment here, sort of. What other questions are good so far? Yes, sir. Yeah.
I'm curious about what's like the break point for smaller projects when you would consider writing a recipe versus just going through the pain of doing something manually, like at the lower bound?
Yeah, it's a good question. I mean, a couple things here. First of all, like, it's my view that, and this is convenient for me, of course, that like I'll say, really the world I want to live in is if you break it, you fix it. So if the Spring team makes a breaking change, they owe us all a recipe that fixes us, because like it's kind of ridiculous that like I go off on this like retreat and I think, I should do functional programming more. Does that sound familiar from Spring Security? It got like suddenly more functional. It's like, I don't know, it's almost like Rob went to some sort of like conference and was like, everything should be more functional. Changed a bunch of APIs, we all have to deal with it. Then a year later he regrets that, rips it all out, and we have to change back again. And so it's just like the unit economics of that change are really upside down. That the framework author made a breaking change and we all have to deal with it on the other side. So I really would prefer that they write them. It's one reason we like having a company behind this, and we work with some of the largest companies in the world. Let's be honest, they apply pressure back to those framework authors. So I only have 30 microservices. I rely on JP Morgan having 30,000 microservices and applying a ton of pressure to the Spring team to say, if you break it, you fix it, and then I benefit from it as a smaller team. So there is that dynamic, I think. But, in general, I don't know. I mean,
So you think about creative changes and algorithmic changes, and
Yeah.
algorithmic changes at scale you want to automate, and then creative exercise where you will make decisions when you make the code change is better to make by a human assisted with Copilot.
Yeah. So a good example, we were at a healthcare company a couple years ago, and they wanted to rip out Oracle, right? Who doesn't move to Postgres? That's a difficult problem for them generally, because those projects don't get started usually, because the question is like, where is the Oracle specific syntax in my org? And so suppose I'm the executive that wants to like rip out Oracle. I go to my principal engineer and I'm like, all right, give me a spreadsheet of all the places where we're using Oracle specific syntax. And that guy's like, how am I supposed to know, right? Like at best you go and ask a bunch of other people, and they all put some stuff on this sheet, and then that a project estimate's coming at the end of that, right? Where we're going to say like, oh, well, you said you could get it done in 3 months, and so it's just one of these. Nobody ever does that because they don't really know where the bodies are all buried. So the first recipe there was just go find every SQL query, every stored procedure definition everywhere in the code. I don't care if it's a YAML, a SQL file, a string literal, a binary concatenation of literals, a Hibernate, configured method, and just emit one of those data table entries for every query that we find, and then rip that query apart into all its constituent parts, all its function calls, and emit a data table entry for each one of those. And then you could do this kind of pivot table, just filter them down to Oracle specific syntax, and then say, where is it? Okay. And so one thing we found was there was a whole business unit that was like, the only change they really had to make was like swap NVL for coalesce, like back to the SQL standard, which is like literally a 1-for-1, just replace one with the other, and that's it. Great, we don't need to involve them in this project anymore. Now to the next people. And there was a whole lot of queries that was like, that whole query is going to have to be rewritten like in some completely different way. And for that, I think, so there is value in, I think, writing these impact analysis recipes that like help you go find all those things, and then you use that as like a continual source of information for how to get it done.
And like, is the collection of recipes that exist, like, for a problem like that, of that type, how often are you able to put that together just with like off-the-shelf recipes versus like having to get your hands dirty writing something yourself?
What we see is something like this, like the Spring Boot, migration, wherever that one was, the 3,300 recipes kind of thing. Like almost always, this is customized in some way, because there'll be some internal framework wrapper around Spring, and that had changes too, or I think of this at, Amex a few months ago. We were trying to do this, and they broke it down. They're like, I don't want to do the whole Spring Boot 3.3 thing all the same time. So they broke it down to like, well, let's just do migrate to Java 17. And then even that, there's 3,000 repos, and like some of them are on some old Jenkins master, some of them are on some new Jenkins master, some of them are on GitHub Actions. None of them have Maven wrappers, and one of those Jenkins masters has an old version of Maven that doesn't support Java 17, and another one does. And so you almost wind up in a situation. So their first reaction is like, I'll try to go list all the projects that are on CI servers that have the right version of Maven on the path. And it's like, the alternative is we just introduce a Maven wrapper everywhere. And then we basically, who cares what version is on the path, right? Like, so the problem got decomposed into mass commit a Maven wrapper everywhere that's at a sufficient version that we could move from 8 to 17, make that through, like, get all those merged, then come back. And then it was like, oh, we have a Hadoop map R variant, which I don't know what that is, but like apparently that needed to change before they could move to 17. So make that change, then do the 17 change, then do the 2.7 change, then do the 3.0 change, then, and that's how you break down resistance. I think like one step at a time. Not idealistic, but that's the reality on the ground, I think, in many cases. Really good questions, yeah. So part of my hope with the model, and something we do face, is like, I've got thousands of recipes. Somebody will be like, I don't know. I don't know what to grab. So rather than ask the question, how is Guava used, I could say, upgrade Jackson, and it goes and finds the right recipe and basically teaches you how to configure it in a way that gets you closer to what you want to do.
Is there a way to add something? I come from medical stuff where there's a lot of ancient systems. And is there a way to say, okay, yes, we're trying to get to Java 17, but we know that in talking to this McKesson mainframe, there's a library here that we cannot move. So, and sort of that has ramifications all the way back because it may not support it, and so all the other things behind it can't support.
So what would you do about that? That's the that library can't move because it uses RMI, and RMI's removed now. That's something we just encountered last week. That specific case, and I think the reality is the base application probably still needs to move forward, but that component has been removed from, say, Spring. We're gonna have to provide an alternative component. We're probably gonna have to fork that other thing or just create a completely different mechanism. And now I've got another recipe authorship exercise here where I'm saying I'm replacing, say, Spring RMI with my internally packaged one that I can carry forward with me. Bolt that onto the set of what it means for me to move there, and then campaign on that.
I think one other thing to notice is that models are really good at writing recipes because they can analyze the release notes and create the YAML for when you write. It will hallucinate a bunch, but the person can fix it. And
yeah.
Mind you, humans at 11 o'clock at night after they've looked at a couple of different things.
I know, right? Exactly, yeah. So I had taken, somebody was like, I want to do struts 2.5 to 6. I'm like, oh my God, he's like, I haven't done struts in 18 years or something. And so I just went and found the release notes and just pasted those at the front, and it starts hammering out recipes. Sometimes the model will just make stuff up, right? Like this, it just made up a recipe that didn't exist, but you kind of fix those things, and then now I have a machine I can use to go hammer this out predictably across the whole estate. And that's really what I think we're looking for, is the best of both. Yeah. Go ahead, Max. It's Max and Jonathan. Yeah, no, man, you're asking good questions.
But I'm gonna. So you mentioned there's a tool that finds relevant recipes.
Yeah.
Yeah. How does that tool work? In a way where it's finding the relevant things. Is it keywords? Is it also using AI behind the scenes?
Yeah, that's the irony. We started with the Lucene index, right? and you know how that works. We had the situation where somebody was like, there's a recipe called find method usages, but they searched for find method invocations. And it was like, well, so it didn't match because I didn't have a synonym in the Lucene, index for invocations and usages. So I actually have a whole blog post on that. We have to find this, but it does take the recipe description text and display name and things of that sort, embed it, and so create a vector representation of that text. The second step, of course, is to embed your query. So it's a regular vector search kind of thing, interestingly, we found that vector search. So if you're not familiar with vector search, you could basically take some text and turn that into an n-dimensional vector of some sort. It could be a 500-dimensional vector. It's just a bunch of floats, and it doesn't mean anything to us really, but it's placing that text spatially in 500-dimensional vector space somewhere. And then imagine you do that for a bunch of things. And now your query you also embed, and it places it somewhere in that same vector space. And now you're just doing similarity, like distance, between the placement of your text in that vector space and all the other ones. And so you can say, like, let's select the 20 nearest matches in that space. What we find is that the nearness metric alone does not indicate relevance. So you could have, of the top 20, you could have one that's much closer and one much further away. They're all still in the top 20. It's not very good at sorting them by relevance. So we do that retrieval step where you're saying I'm going to retrieve a certain number of these based on their vector similarity. And then you follow that by something called a re-ranking. And so there's small models that are just trained to do only re-ranking of pairs from a set that you've pre-selected. And so we pass the smaller subset into a re-ranker, and then that does tend to sort them by relevance. I think a lot of people do retrieval, not a lot of people do re-ranking as a step. I'm trying to remember what that's called, because this is a really good blog to read, where we go into really gory detail on how that's done. And obviously it's applicable to every other. Yeah, this one. Yeah. So if you look at that URL up there, take it. It goes through how we did the embedding and then ultimately the re-ranking somewhere down here, and it actually shows the models and how to test test the models and for accuracy and so forth. For these, we use just open source models off of Hugging Face that are super small, and the reason why they run on CPU only. No GPUs.
You can run as a sidecars to Java microservices and just provide search results.
You could also ask. OpenAI to do a embedding for you. It's just a bit like, I don't know what the right analogy is, but you're using kind of like a too big a tool to do a small job in that case, but. My goodness, this changed. Select tasks. So if I went to just look at re-ranking, for example, I would just get rid of, this is really different than it used to be.
Yeah. You have to do a contest for re-ranking? How does it rank it?
There are models that are open source that are trained only on re-ranking as a task. So you see that in the task type. I just got rid of it, but when you look at retrieval, honestly, they changed this quite a bit. So I think I'm looking at the right thing. I think the same point is true here. Is if you look at one of these leaderboards, you'll find like the amount of gosh, I just don't know where it went. Anyway, the point is there's a leaderboard out there, and it's tempting to just like always want to pick the number one thing. But oftentimes, like the number one model on the leaderboard will be like 30 billion parameters or 57 billion parameters or something. It'd be huge. And so you require like 500 gigs of memory to run it, And you're looking down the leaderboard on the like performance score, and you could just look to number like 12 on the list, and the performance is like a 0.5% difference, but this one only requires 2 gigs of memory and a CPU. And so you really do have to think about like, especially if you've got some way of validating the result, it's possible to always select models that do specific tasks like retrieval or re-ranking that are much, much, much cheaper than using the large foundation models. For text generation, not so great, right? A lot of the open source models. Yeah. The other factors to always consider here is our latency with these models. So the more parameters a model has, the longer the latency is going to be. It's just more network to get through. And so oftentimes you selecting a smaller model is actually better for you in terms of tail latency in the end. If I have to pass 100,000 things through and I've got a 7-second response time, it's going to be a lot longer than if I could get down to half a second response time, right? Yeah. Yes, sir.
So about re-ranking models, I remember having a project like a year ago. I remember getting like mixed results with re-ranking models.
For sure.
Actually make it worse.
Yep.
And there was like a custom kind of re-ranking function I found on a blog at Pinecode, the website.
Mm-hmm.
That was a lot more useful than the actual like models out there that are.
And it was a deterministic one?
Yeah.
Yeah. That's not surprising at all. Yeah. That's good to know. Yeah. Yeah.
Content sources attention as well.
Yeah. Yeah, the one other thing here, since we're talking about a random grab bag of things with respect to models, I think, and we talked about context earlier, I think it's not, I don't hear a lot of understanding that like the more you shove into a context window, the weaker the attention mechanism gets. And so it's one of those hope is not a course of action things. People are always like, oh, the context window keeps getting bigger, right? It's like, yeah, but you give it a whole book at once and then ask it to focus on one specific little fact. It's not going to do well at that. Just like a person wouldn't. I don't like to anthropomorphize these things, but
Overload models, the same issue.
yeah. Well, anyway, I think that was a lot of the things we could. I hope there's a broader discussion afterwards. The one thing, because we're here, we do have a conference running in May. It's important to us that you all come from Toronto to Miami. I know it's a hard ask because we came from Miami to Toronto.
It's too hot.
In May, it's great. It's great. No, he lies. He's in it. But yeah, we'll have Josh Long there. We'll have Venkat. We'll have all those typical people. Spotify, IBM, Google. If you don't listen to Chris Jenkins' podcast, it's awesome. Developer Voices. He gets into lots of crazy topics like this. ThoughtWorks. A lot of great people there. So we'd love to see you down there.
What can you expect from the conference?
Yeah, so there's 3 things happening at this one. So first of all, this is a no fluff, just stuff conference for any of those that are familiar with Jay Zimmerman's work over the years. We have 3 tracks: a developer track, a leader track, and because I'm there, hack track. So the hack track is going to run for 3 days, and we're going to have various experts of different kinds of things there. So we'll have expert open rewrite recipe developers. We're going to have some folks there from Azul, StackLock, I'm not sure, DivBlue, I think. And there'll be tables set up where basically you bring your machine with hopefully like a lot of your work stuff on it, and we do some work with you on something. So for us, I know that means let's do a Java 17. If you come with a laptop with 500 repos on it, we're going to get them to Java 17, and you're going to go home with that. That's the idea. Cool. Thanks. Appreciate it. Cheers.